Okay guys, so today in class we talked about position versus time graphs, and tonight you're going to learn a little bit about velocity versus time graphs. A velocity versus time graph is a graph where you have the velocity of an object on the y-axis compared to the time that we have on the x-axis. And so if we had a graph of velocity versus time, and we'll start out very simply, and let's say we had a graph that looks like this. Okay? So what we have is an object starting out with some positive initial velocity, v0, and going up to some even higher final velocity, v. And they do that from a time of 0 up to some time t. And so if I look here, I have 2 points on my graph. I have this point here, which is going to be 0, v0. And I have this point up here, which is going to be t, v. So just like we did today in class, we're going to talk about slope. And remember that slope is always going to be y2 minus y1 over x2 minus x1. So in this case, our slope is going to then be v minus v0 divided by t minus 0. Which could then just be simplified to v minus v0 over t. And as we learned in class yesterday, we know that v minus v0 over t is the mathematical equation for acceleration. So on a velocity versus time graph, the slope will always equal the acceleration. So just like we discussed with our position versus time graph, we can have 3 types of slope. And the first type of slope that we have here is a positive slope. So if we see a positive slope on a velocity versus time graph, then that means that we have positive acceleration. And our second slope that we see here is going downhill. It's going to be a negative slope, so that would represent negative acceleration. And then the third line that we see there is a horizontal line which has 0 slope. So if you see a line like that, you know that you have 0 acceleration. So we talked today in position versus time graphs about curved lines. And we're not really going to deal with them much with this type. But I just want you guys to think about it, and we'll talk about it in class tomorrow. What would a curved line represent? And it's just an interesting question. We'll talk about it briefly tomorrow, but in this class we won't deal with curved lines on a velocity versus time graph. We'll only deal with curved lines on a position versus time graph. So now we're going to analyze the motion of the object represented here in this velocity versus time graph. Just like with the position versus time graph, the first thing I like to do is go ahead and kind of split that up into sections. And so the first interval I really seem to care about here is from 0 up to 3 seconds. So right along in there, okay? Because at that point my line changes. And then my next change seems to occur at 5 seconds. So we'll split it up there. My next change occurs at 7 seconds. So we'll split it up there. And then I have another change at 8 seconds. And then I'm actually going to care about it crossing the x-axis here, so I'm going to deal with this right there as well. Okay? So, first interval I care about is from 0 to 3 seconds. Okay? And if I look from 0 to 3 seconds, my velocity is up above the x-axis, so velocity is positive. My slope is positive, which means my acceleration is positive. And if velocity and acceleration are both positive, we're moving right and we're speeding up. Okay? Now, from 3 to 5 seconds, my velocity is still positive because I'm still above the horizontal axis there. But now I have zero slope, so my acceleration is 0. So if my velocity is positive and my acceleration is 0, then now I am moving right, but I'm doing that at a constant speed. Alright, for my next section, I'm still above the horizontal axis, so my velocity is still positive, but now I have a negative slope, so my acceleration is negative, and if I have a positive velocity but a negative acceleration, then that tells me that from 5 to 7 seconds I am moving to the right, but I am slowing down. Okay, next section, from 7 to 8 seconds. My velocity is still positive because I'm still above that horizontal axis, and my acceleration now is 0 because I don't have a slope. So if I have positive velocity and 0 acceleration, then from 7 to 8 seconds I am moving to the right at a constant speed. Okay, then we look at 8 to 9 seconds. Now from 8 to 9 seconds, we have still a positive velocity because we're still above the horizontal axis, and a negative acceleration. If we have positive velocity, negative acceleration, we are moving to the right and we are slowing down. And in fact, right at 9 seconds, what does the object do? You tell me in class tomorrow. Alright, then from 9 to 10 seconds, now we are below our horizontal axis. So now we actually have a negative velocity, and we also have a negative slope, so we have a negative acceleration. And if both velocity and acceleration are negative, now we are moving to the left, and we are speeding up. So now we're back to a very, very simple velocity versus time graph. And so what we have going on here is just an object that's moving with a constant velocity. And anytime we have an object moving with a constant velocity, then we can just think of that as an average velocity. And as you guys know, the average velocity is always the displacement of an object divided by the time that it took. Okay? So, we have an object here at some speed v, and it goes that speed for some time t. And if we take this graph, we can kind of turn it into a rectangle. And if we rearrange our equation to solve it for displacement, we are going to see that the displacement equals the average velocity times the time. And what you will also know is that the area of this rectangle is going to be the velocity times the time. And the cool thing about this is it doesn't just work for this very, very simple graph. It works for any velocity versus time graph. And so what we have here then is that the area under the curve, and when we say the area under the curve, what we mean is the area between the graphed line and the time axis. And for any velocity versus time graph, the area under the curve always equals displacement. Alright, now we're going to go to the same graph that we were looking at earlier, but now we're actually going to use this graph to figure out the total displacement. So we're going to do the displacement for the entire 10 seconds, and you could really do it for any interval you wanted. So what I have to do now is I have to figure out the area under the curve for this graph, and I have some positive area and I have some negative area. So I'm going to show you my positive area here in blue. Okay, so all of that shape right there would be positive area. That's going to represent positive displacement where we're moving to the right. Okay. But then we have a little bit of negative displacement as well in this little triangle down here beneath the time axis. That is going to be some negative displacement. So let's deal with our positive first. So I've got a strange shape there, but it's also a shape that can easily be split up into rectangles and triangles. Just like that. And you could do a different combination of those as well if you wanted to. Alright, so if I look at this first rectangle down here at the bottom left from 0 to 3 seconds, that is 3 wide and 1 tall, and 1 times 3 is 3. Then if I look at the triangle above it, it is 3 wide and 3 tall, and triangle is 1/2 base times height, so it's going to be 1/2 times 3 times 3, so half of 9, which is 4.5. If I look at the rectangle next to that, it is 2 wide and 4 tall, and 2 times 4 is 8. If I look at the rectangle next to that from 5 to 7 seconds, it is 2 wide and 2 tall, and 2 times 2 is 4. If I look at the triangle above that, it's 2 wide and 2 tall, and so 1/2 base times height will be 1/2 times 2 times 2, which gives me an area of 2. Look at the next rectangle, it is 1 wide and 2 tall, and 1 times 2 is 2. Look at the triangle next to that, it is 1 wide and 2 tall, so 1/2 times 1 times 2 is 1. Okay. If I go down to my negative area there, I have a triangle that is 1 wide and it's also 2 tall, or negative 2 tall if you want to think of it that way. So this one here is going to be -1. So now it's very simple. If I want to find my total displacement for the entire 10 seconds, it's going to be 3 plus 4.5 plus 8 plus 2 plus 4 plus 2 plus 1 minus 1. So when I get that total area, it's going to be 23.5 meters. So what that tells me is that at the end of the 10-second time period, I'm 23.5 meters to the right of where I was at the beginning of that time period. And we can find the displacement for any time interval by just taking the area underneath the curve during that time interval. Alright guys, I'll see you tomorrow and we'll go over your position versus time graph practice and also answer any questions you have about velocity versus time before we start practicing that. See you then.